Dear students, let's talk briefly about dispersion of light. There are two types of lights, monochromatic light and polychromatic light. Monochromatic light, an example of it is like laser light that you see here, for example. This is monochromatic light. You see, it's blue. It could be green light. It could be yellow light. It could be red light. That is already monochromatic light. And as you can see with monochromatic light, that is already of individual color or wavelength. It does not spread as it gets outside of the prism, which is used for dispersion of light. Because it's monochromatic color, because it's of the same wavelength, it does not spread. Even though the optical path length here is a little bit or slightly different, it does not actually spread. It remains the same. So when we talk about dispersion, the light that is mostly important with dispersion is polychromatic light, white light. Let's go and test that. So now if we come back, this is white light. As you can see, if you pass white light, which is polychromatic, why polychromatic? Because it has many wavelengths, it has many colors combined together within it. If it goes through a prism that you see here in the middle, you can see that the white light is now divided into various colors ranging from red, to yellow, to green, to blue. As you can see on this side, that the white light has been separated into individual wavelengths and colors like the color of rainbow. This is what we call dispersion of light by using a prism. But as I mentioned, of course, again, in today's world, prism is less and less used because prism is big and bulky. So there are things called diffraction grating, which changes the concept from dispersion to diffraction, but it does almost the same thing. And it's the same principle and the same phenomenon that you can observe when you use a DVD disc, which has grooves in it. All the DVD discs has grooves in them, and if you shine white light on them and place them at specific angles, you will see the rainbow colors coming out of that, as we are going to see using our setup. But yeah, this is all about polychromatic light and monochromatic light. Again, monochromatic light has individual wavelengths, so even when you pass them through the prism, they don't change. But polychromatic light is having many colors together. So white light is polychromatic light, and if you pass it through the prism at the outside, because of the optical path length difference, the white light is dispersed. And because of traveling at different lengths, and because of varying speeds, let's say, in a way, because if you are traveling at different paths, it means it's the same white light, but now because it's delayed to get to a certain location compared to the other part of that white light, it enables that white light to be divided into these individual colors that we call monochromatic. Or so this can turn this from polychromatic light to monochromatic light, because now we can have individual colors and be able to see them and even extract them for several applications. So yeah, that is important for us to understand as far as polychromatic light and monochromatic light, and many wavelengths and a single wavelength of light. Thank you very much.